Okay, so this is activity 2. Activity 2, we're using an artificial membrane, okay? And so for this, you need dialysis tubing. Whoops, that's not this one. So dialysis tubing is what they actually use in dialysis. So if you remember, the kidneys, their function is to filter blood, and they do it through the loop of Henle in the nephron. And when they're going down, they're permeable to one thing. When they're going back up, they're permeable to another. And it all works by tonicity. Hypertonic, hypotonic, that's all it works by. And so dialysis tubing is meant to mimic that. And so we're going to use it as an artificial membrane, and it's permeable to some things and not permeable to others. And depending on how long it is soaked will determine how permeable it is. So it depends on when your lab is. So there's no right or wrong answer to this one. It just depends on when your lab is and how long it's been soaking. The lab tech will make sure that all of them have soaked for at least an hour before you get it in lab. But it could have been soaking for 8 hours. We really have no idea. So you're going to have your students take the dialysis tubing out. It's very slimy, okay? And it looks like a clear bag. I'm actually going to bring it over and show it to you. Okay, it's clear. It's a clear bag, but it's actually a bag. Like it opens in the middle. So if you kind of, you see how I did that between my fingers? It opens into a bag. It's like a little Ziploc baggie, except it's open on both ends, okay? So it opens into a bag. So what you're going to have the students do, and this is all in their directions, they should follow directions. They're going to take a tiny rubber band, and yours might be white, mine are black. You're taking a tiny rubber band, and they're rubber banding one end of their bag shut. We want to make sure, oh my gosh, I'm getting this. We want to make sure that it's watertight on one side. Because we don't want things leaking out, we want them diffusing out. And I'll show you this when I get it all finished, okay? Alright, so I've got it tied on one end, and then it tells them to fill it halfway with 10% starch solution and halfway with 10% glucose solution. So I have my two solutions here. These are the starch and the glucose. And these should be Lab Tech, these should be in their little bin also. Okay, so they should have a 10% sodium chloride solution, a 10% glucose, and a 10% starch. So you're going to take your little bag and you're going to try to fill it as delicately as you can without ripping it. Halfway, and make sure they stir it. See, I'm kind of stirring it up so it's dissolved. It just gets kind of ridiculous. So I'm just going to count how many droppers I do. So I did 2 of that. So I'm going to do 2 of the other. And make sure they don't cross-contaminate their solutions, right? So this is my dropper for this. And this is now my dropper for this. Whoops, I just spilled. And I'm going to make sure I stir it. So I'm going to do 2 full droppers of the glucose. Ooh, that might be a lot for my bag. And the bags are just kind of haphazardly cut, so just do your best. All right, so then they're going to have a beaker similar to this, but a bigger one. And they're going to, and actually it doesn't matter, we'll just use this one, but I need a little more water. So you need it filled all the way to the top. Okay, and they're going to put the bag in, and then they're going to use the rubber band to seal it around the top. And I'll bring this up and show it to you. This is kind of a big rubber band for this little tiny beaker. You guys are going to use a little bit bigger beakers than this. You'll use the, what are these? The 500 ml beakers. Okay, so I'm going to bring this up and show you so you see my setup. Let's see. So you see I've got in the beaker the little bag. It's sealed on one end, and then I've got it just kind of clipped to the side of the jar. Whoops, it actually fell out. I'll fix that. With my rubber band. Okay. Then, and if they want to use 2 braces rubber bands and actually seal the whole thing, that's fine too. We're just trying to cut down on cost. Okay. Then they're going to fill the water with iodine. So they should have a little dropper of iodine. So the lab tech will have a little dropper of iodine sitting in their bucket also. And they want to make the water look like like urine after you've had lots of sugar. So it should be pretty brown. So probably the lab tech's going to need to refill the dropper bottles periodically throughout the week. Or you guys can do it too. You're capable. Okay? So they want nice brown water. And then they're going to set this aside. And this has to sit for 20 to 30 minutes. So they should be watching the time. And we'll come back to that. But while they're waiting, number 7 asks them to make predictions. So let them do this and then talk about it as a group. So is the glucose solution small enough to pass through the membrane? We don't know. Okay, and we're going to find out. If yes, how could you tell? What test could you run to see if glucose made it out of the bag into the fluid in the beaker? Well, they should remember from last lab that the Benedict's reaction will tell them if there's glucose in the water, right? So they're going to run the Benedict's on the water surrounding the bag, not in the bag, the water surrounding the bag. We know there's glucose in the bag. We want to know if glucose made it out. But let them come to that. Don't tell them. Ask them, how much you test for glucose? Then the next one says, is the starch solution small enough to pass through the membrane? Remind them that starch is a much bigger molecule than glucose. Glucose is a single monosaccharide. Starch is a polysaccharide. So have them think, which one do they predict will make it through the bag? Will both make it through the bag? Will only one, none, make it through the bag? If if starch makes it outside the bag, is there a test you could run to look for starch? And they should remember from the last one, again, let them come to this, but they should remember from the last one that iodine will test for starch. Okay, so if there's starch that leaks out, this iodine solution should start to go kind of black, purpley color. Okay, and then the last one says, is iodine small enough to pass through the bag? Now remember, the iodine's on the outside of the bag. We want to know if it's going to pass in. So let me just draw this for you. So we have our beaker. We have our iodine solution. And then we have our little bag that's hanging in there. Okay, there's my bag. And the bag, remember, has glucose in it. Let's see, I'm going to draw that in green. The bag has glucose, and it also has starch. I'll do starch in blue, or let's do it brown. It also has starch. And the iodine is on the outside. So the question is, number 1, did the glucose make it out? And if so, then we can take this solution and run the Benedict's. Did starch make it out is the next question. If starch made it out, then the iodine should react with the starch and start to turn black. Or purple, I guess. And then the last question is, did the iodine make it in? Was it small enough to go in? Iodine's very small. If the iodine goes in, what's going to happen? Then instead of outside the bag, inside the bag should start to turn blackish purple. Okay? So we have 3 different predictions that can help us know how big are the pores in that particular bag. Okay? But it does have to sit for 20 to 30 minutes. So we're going to let that sit. And in number 8, they're going to record at the beginning and at the end what the colors are and what conclusions they can draw. What made it in, what made it out, how big, how small. Okay? So that's activity 2. So we'll do activity 3 now while this is incubating.